Keji, you need to share the whiteboard with him, with her. Hey, nobody write down anything on the whiteboard except for the hosts. So Eva gonna present the first two problems. Oh, Eva, can you please copy paste the first question on the screen, like so everyone can see what a question we are discussing? And
Um,
then you also press the eyes on me. It's a button on the top right corner. Did you see the top right eyes on me? Yeah. So everyone gonna follow you, okay? Oh, Eva, you can start right now. Yeah.
okay. Um, so first, does anyone have a solution that they want to present? Yeah. You can go ahead.
So we have that 5x plus y is congruent to 3 mod 7. And then we have x plus 5y is 6 mod 14. So when we add these two equations, like just the 5x plus y and x plus 5y part, we get 6x plus 6y, and that is 6 times of what we need to find. So that this must be divisible by 6 because it asks for the integer value. So this must be divisible by 6. So and then we go so for the first one, we can have like the first few values are like 3, 10, and 17. And for the like x plus 5y, we have like 6, 20, and 34. And then we notice that if we have the 3, then like summing up with the 6 will give us a 9, with the 20 will give us 23. And then we realize if we have a 3, none of these numbers, 9, 23, none of these numbers can be divisible by 6 because it must be even, but 3 plus an even number, which we have here, is not even. So that means we must go to 10. So for 10, we have 16 with the 6. And we have with the 20, we have 30. And then this is our first number that's divisible by 6. But yeah. And also 17 can't work the same reason as 3 because it's odd. So, and then we have 30 is 6x plus 6y. So x plus y is 5. So is the answer 5?
Yeah, that is the correct answer.
Okay.
Um, that is a solution that works, but I want to mention another one. So, if you start with okay, so you start with 5x plus y is congruent to 3 mod 7, and x plus 5y is congruent to 6 mod 14. Is there a question?
I have an easier way.
Oh yeah. Sure. Go ahead.
So like basically the smallest, like it's basically 5x plus y is equal to like 3 mod 7. So you just 3 plus 7. And then basically like x plus 5y. The smallest is 6 plus 14. So then if you solve it, you'll get like 5.
Yeah, but I think it just works in this question because the numbers are really nice. But in general, you can do something like this, where here you have two equations with different modulus values, right? So the first thing we want to do is make it so that they have the same modulus value. So this first equation, you can change it into 5x plus y is 3 or 10. Oh, 10 mod 14, right? And then you can combine uh these two equations yeah, you can combine those two equations and you'll get 6x plus 6y is congruent to 9 or 16, which becomes 2 mod 14, right? And then this you can factor into 6x plus y. And since x and y are integers, their sum must also be an integer. So this expression should be even. And 14 is also even. So 9 mod 14 isn't gonna work. So it has to be equivalent to 2 mod 14. And then from here, you can just try out different values that are equivalent to 2 mod 14 that are also divisible by 6. So you can start with 2, which obviously isn't divisible by 6. And then you add 14 to get 16, and that's not divisible by 6. So you can add 14 again to get 30, and that is divisible by 6, so you get that the minimum value of x plus y is, yeah. Okay, and that's all for question 1. So, one second. Okay, I think we can move on to number 2. Does anyone have a solution that they want to present? Okay. Okay. So, here we're given a recurring decimal, 0.abc repeated, and we want it reduced to a fraction in simplest forms, and you want a number of different possible numerators where ABC aren't 0 or the decimal isn't equivalent to 1. Okay, so first we have to know how to express a repeating decimal as a fraction. So if we write this out, we get, and it goes on, right? So if we assign this a value x, for example, and then since there's 3 digits that are repeating, we can multiply x by 10 to the 3, which is 1,000. Okay. 1,000x with ABC and so on. And if we subtract these two values, you'll notice that the decimal portion of this number cancels out. So you'll get 999x is equal to ABC. So then that means x is equal to ABC over 999. Okay, so this is a fraction that we're trying to express, and we want to express it in the simplest forms. So that means there's going to be a little bit of reducing. And so we have several cases that we can consider, and we can do casework on the denominator. So we can say our first case is that the denominator, we'll call it that, is equal to 999, which means that there's no reducing, and we should probably factor 999 first. It's equal to 3 to the third times 37. Okay, so that means that the numerator, ABC, is co-prime or relatively prime to 999. And all that means is that it doesn't share any common factors with 999. And since we know the factorization of 999, we can calculate the number of numbers that's less than 999 because it has to be a fraction less than 1. So the numerator has to be less than 999. And we can calculate the number of numbers that are co-prime that are less than 999. So first, we can do this with complementary counting, where we consider all the numbers that share a factor with 999, and we take that away from the total number of numbers less than 999. So between 1 and 999, there's 999 numbers. And then first, we can take away the multiples of 3 by doing that. And then we can take away the multiples of 37 by doing that. Right, but here you've double counted numbers that are multiples of both 3 and 37. So you have to add back 999 over their product, which is that. And then this gives you 648, right? Because that's 333, that's 27, and then that's 9. Okay. So that's your first case. And then your second case that you can consider is that the denominator is divisible by 37. And we want to consider this case as well as one of the other ones, because here we see that the factorization of this has factors of 3 and 37. And since we've considered all the numbers that are co-prime to 999, any new numerators that you're going to get are going to be numbers that are not co-prime to 999. So we can instead say that the numerator is co-prime to 37, but not to 3. Does that make sense? So that means that multiples of 3 less than 37 are also going to be possible numerators, right? And then these are new additions to our count because these multiples of 3 wouldn't have been counted as a numerator for over 999, right? So we take the floor of 37 over 3 to get the number of multiples of 3 less than 37, you get 12. Okay. And then our final case, case 3, is the denominator. Denominator is divisible by 3, which means that for us, it has to be a multiple of 37, following the same logic that we used in case 2. And you'll see that 999 is 27 times 37, which means that the largest power of 3 that could be a possible denominator is 27, right? But then since this has to be a fraction less than 1, and 27 is less than 37, that means we get no additional cases, no additional values of m from here. So we have 648 plus 12, and you get 660 as your final answer. Are there any questions? Yeah.
It's not related to the solution, but if this question were on the real AMC 10, what number would it be?
Oh, I don't know, because AMCs are hard, right? But this problem, it's not super difficult. So probably like, oh no, 10, 12.
Okay.
Is there any other opinion on this? Because I'm not sure.
I think it's gonna be like around 15 or something.
Oh, my bad. Okay. Okay. Any other questions? Okay.
All right, I think it's my turn to present. I'm Keji. I'll be doing problem 3. Hang on. All right, and so we have, let me put in the picture of problem 3 first. All right. Okay. All right, so we have little baby infant learning the names of different animals. And so he loves juice, and he's rewarded with juice every single time that he successfully says the name of an animal. And so we have these 3 animals, bear, squirrel, and cat. And so, and each time he says bear, he gets one teaspoon of juice, which is like really little. I don't know where he got really cruel parents, but either way, he gets 2 for saying squirrel and 3 for cat. And if we got 20 teaspoons in total, how many different ways could he have been saying these animal names? So firstly, we can set we need to set some variables. This is clearly an algebra problem. And so let the number of times he said bear be b. So we have b, and then plus 2 times the number of times that he said squirrel. So 2 times squirrel, 2s, plus 3 times times he said cat, so plus 3c. That will be equal to 20, and that and B, S, and S, C, and B will all be greater than or equal to 1. And so this is a Diophantine equation, and the best way that we deal with Diophantines is to actually use casework. And here we need to choose our casework wisely because we don't want to end up with too many cases. So we pick C as the one that we set our cases upon because it is the biggest one that determines the value. Oh, what is this? And so let's say C is equal to 1. Then we have B plus 2S is equal to 17. And we have the values of 1 comma 8 for B and S, and then 2, I would say 3 comma 7 and all the way to 15 comma 1. And so that would give us 8 solutions because S would go from 8 to 1. And that is that for our first case. Now let me move this out of the way. All right. For our second
Actually,
case.
sorry to pause you. Like, did you
Yeah.
click the ice on you? Ice on me?
Oh yeah, my bad.
Yeah.
Okay.
Okay. Yeah.
Yeah, here we go. So for our second case, I'll do it here. Case number 2, we have C is equal to 2, and then we have B plus 2S is equal to 14. And then our cases will be 2 comma 6, 4 comma 4, and all the way to 4 comma 5. And then I think we go all the way to 6 comma 1. And then again, C will be going from 1 to 6. That would be 6 solutions for our second case. Case 3, C equals 3. Again, this is starting to get redundant, but it will be even worse if we try to say like use B as a case. Using C as a case actually decreases the number of solutions we have. And so again, C equals 3. We have that B plus 2S is equal to 11. This I'm not going to list the solutions out. There are 5 solutions here. C equals 4. All right. Can somebody tell me the amount of solutions we have if C equals 4? Raise your hand. Anybody? Jen Yu.
4?
The answer is actually 3. I think you might have overcounted because when our solutions are actually 2 comma 2. Wait, sorry, 2 comma 3. When we have B plus 2S is equal to 8. 2 comma 3, 4 comma 2, and 5 comma 1. 6 comma 1. You might have counted 8 comma 0, but that is not a valid solution because we have that S is equal to 0, but because of the problem definition, that is not right. And so that here we have actually 3 solutions. For C equals 5, we have 2 solutions. And then for C equals 6, we would actually have 0 solutions because we have B plus 2S is equal to 2. And we know that S has to be greater than or equal to 1. And when S is equal to 1, it gives B equals 0. So there are actually no solutions here. And so we tally them up. And so that is all our solutions. If C continues increasing, we would actually get a negative number. And so our total number will be 8 plus 6 plus 5 plus 3 plus 2. 8 plus 6, 14. 14 plus 5, 19. 19 plus 3 plus 2, that'll be 24 solutions. And we're done. Does anyone have any questions? Do you have a question?
This is for if the order doesn't matter, right? So how would you know that if the order matters or it doesn't? Because it didn't really clarify that.
technically we should assume it doesn't matter because if it does matter, we'll have a pretty nightmare, and this problem will not be in MathDash.
I thought order does matter, and I got like some answer in the millions
It shouldn't be in the millions.
or like 100,000s.
Yeah, but like he does the problem like would have been way too hard, but like does here or it does not matter. And our answer is 24. Any other questions? All right, cool. I'll hand it over to Zanda for problem 4.
Okay, hello guys. My name is Zanda, and I'll be going over problem 4 with you guys. So, first of all, does anybody have a solution that they would like to present? Cabra.
Zanda, please click the eyes on me.
Oh, okay.
Okay.
Okay, so basically, so like let's draw the triangle first. So we have A, B, C, and then so this is wait, first can I know what the correct answer is?
The correct answer is 1,195.
Okay. Wait, wait, okay, yeah. So this is our diagram, and then we have like A, B prime, C prime here. So now, like, so the special thing, so we have wait, let me double check the question. We have AB is equal to 14, AC is equal to 13, and BC is equal to 15. So the special thing about 13, 14, 15 triangles is that it's just it's just a 9, it's just a 9, 12, 15, and a 5, 12, 13 triangle put together. And you can find that by just like setting up variables. But since I already know that, so we can put it like here. And then now, first we'll calculate the area of ABC. It's just 14 times 12 divided by 2 because that's the altitude to AB. And then that's equal to 84. So now so we try to find the sides of like AC prime, C prime, B prime, and B prime, A prime, because we might get like some similar triangles or some special triangle. So first we'll calculate B prime, and we can find this by AB prime is just wait, so for AB prime, let's say like so wait, yeah. So we know that we can figure out the altitude B prime by because we know that so like if we can calculate the area another way, like the area is also B prime times 13. So we and divide by 2. So we get that B prime is equal to 168 divided by 13. And then what we can do is we have a right triangle A, B prime, B. For AB, let's write it with a denominator of 13. And so it's 13 times 14 divided by 13. And B prime is 12 times 14 divided by 13. And so we have a 5, 12, 13 triangle again. And that means we have AB prime as 5 times 14 divided by 13. And now we see if we have any similar triangles. So AC prime is 5. So the ratio of AC prime to AB prime is 14 over 13. I mean 13 over 14. So basically so now we know that A, B prime, C prime is similar to ABC. So the ratio of their sides is like 5 over 13. And so the ratio of the areas is 5 over 13 squared. And then once we get once we get a b double prime and a c double prime, then we know that they'll be similar with this ratio to a b prime c prime. So our areas are basically just 84 plus 5, so 25 over 169, which is 5 over 13 squared, 25 over 169 times 84. And then we have 25 over 169 squared times 84. So we have a geometric series, and we need to and it's an infinite geometric series, and we need to calculate the sum. So using the formula a over 1 minus r, we get a is 84, and 1 minus r is going to be 144 over 169. So it's going to be 169 over 144 times 84. And this will simplify to, I believe it's, let me see. I think it's 1183 over 12. So the answer is 1195.
Yeah, that's the exact way how to do it. So basically, first what you'd want to do is you want to find some relationship between AB prime C prime and the original triangle ABC. Here you found that they were similar using your method, but I think there should be like a faster and quicker method that you can do this. So let me draw the triangle first. This is A, this is B, this is C. AB is 14, AC is 13, BC is 15. And then you make the altitude here to C prime. You make the altitude here to B prime. So what you notice in this diagram is the angle BC prime C is 90 degrees, and same with the angle B prime C. Now, if you see this, you should automatically know that the 4 points BC, B prime, C prime lie on the same circle, where BC is the diameter. So these 4 points are concyclic on the same circle. So basically, for concyclic quadrilaterals, the opposite angles add up to 180 degrees. So in this case, angle C, this angle, plus this angle is equal to 180 degrees. But you also notice that the angle AC prime B prime, which is this angle, plus this angle is also equal to 180 degrees. So now you can automatically get that the angle AC prime B prime is equal to the angle AC prime ACB. And obviously they also share the angle A. So now you can know that the two triangles AB prime C prime and ABC are similar. And you try to find the area using the same method as what you did. So you know the area of triangle of ABC is 84. And then AB prime C prime is 84 times 25 over 169. And then it just keeps adding like this. So it's 84 and then 1 plus 25 over 169. And then the common factor is just 25 over 169. And then using the same thing that you did, which is S is equal to A over 1 minus R, you can get that S is equal to 84 over 1 minus 25 over 169, which is, the final answer is 1183. out of 12, and then you add these two numbers, so then you get 1195 as your final answer. Does anybody have any questions? Okay, I guess that is it for problem 4.
Okay, thank you so much. Thank you, Zanda. So thank you for like Ava and Koji and Zanda, like hosting this this Zoom session. Yeah. So if you have any questions, if no question, we're gonna end the meeting very soon. And before that, I'm gonna make announcement, I'm gonna make a correction here. Like for the question 2, actually, yeah, somebody says on the problem sheet it says the points for the question 2 is 3 points. Yeah, it's 3 points. It's not 2 for this one. Okay, so totally for this test we're gonna have 11 points if you answer all the question correct. And in a couple of days I'm gonna release the result. Yeah, we're gonna end the meeting. Oh, so Koji, can you please end the recording?